Okay, so I apologize if you come back to watch this video. I forgot to record at the very beginning, but so we're going to multiply these two numbers. Again, I know that 3.85 is actually a negative number. 3.7 is a positive number. We're just going to multiply them and then we'll go back and address those decimal products. So 7 times 5 is 35. We'll carry our 3. 7 times 8 is 56. Plus 3 is 59. Carry the 5. 7 times 3 is 21. Plus 5 is 26. We'll put a 0 because now we're moving to the 3, which is in the tens position. So 3 times 5 is 15. We'll cross that 3 out and we'll add a 1. 3 times 8 is 24. Plus 1 is 25. Cross this 5 out and now put a 2. 3 times 3 is 9. And 9 plus 2 is 11. We're going to go ahead and add these up. 5 plus 0 is 5. 9 plus 5 is 14. Carry your 1. 6 plus 5 is 11. Plus 1 makes 12. Again, carry 1. 1 plus 2 is 3. Plus another 1 is 4. And then we'll bring the 1 down. Now, we're not done here, right? We can't say that our answer is 14,245 because we're ignoring the fact that that first number had 2 decimal points and the second number had 1 decimal point. So 2 decimal points plus 1 decimal point means that our answer must have 3 decimal places. So we're going to take our decimal, we're going to move it once, twice, 3 times to get 14.245. And then because we had a negative times a positive, our final answer is negative. So what they were saying about you ignore the decimal points and the 2 numbers, you multiply them together as if they were just normal multiplication. Then you go back and count up the number of decimal places in each number, add those number of decimal places together, and that's how many places in your decimal point needs to be in your answer. Again, we know we want to follow that the positive times a positive is a positive, or a negative times a negative is a positive, or finally, if the signs don't match, meaning a negative times a positive or positive times a negative, our answer will be negative. So if we go back to that previous page, so there's that whole like signs, unlike signs. And then in terms of orders of operation, all the normal order of operations apply when we're dealing with decimals, okay? That's all they're trying to say there. So if we look at number 4, I want us to do number 4 before we go down to number 3. So go ahead and multiply those numbers in number 4 and send me your answer in a direct message. Okay, so when we multiply these together, our product is going to be positive because they're both negatives. And then 4.5 times 9.73 gives us 43.785. So in number 2, we want to simplify. Now we're dealing with order of operations because we've got those parentheses, right? We've got something actually happening inside the parentheses. So we want to simplify this subtraction first. So we're going to do 9.7 minus 4.4. 7 minus 4 is 3. 9 minus 4 is 5. So if we simplify, instead of 3.28 times 9.7 minus 4.4, this becomes 3.28 times 5.3. And then once we simplified, now we're just multiplying those numbers as they are. So we'll do 3.28 times 5.3. And we just move through it, right? So again, sorry, I'm moving through quickly. I'm not explaining what I'm doing. 3 times 8 is 24. So I put the 4 down and carried the 2. 3 times 2 is 6 plus 2 is 8, which is why I have an 8 written there. 3 times 3 is 9. So I put that down. I put a 0 and then I move to the next place. I've got 5 times 8, which is 40. So I put another 0 down and carried the 4. I crossed that 2 out because that was my carry from the first round. 5 times 2 is 10 plus 4 is 14. We'll carry 1. 5 times 3 is 15 plus 1 is 16. We'll go ahead and add these together. And then we have to count up our decimal places. I've got 2 decimal places in the first number, 1 decimal place in the second number. Therefore, my answer needs to have 3 decimal places. And I end up with 17.384 as my answer. Again, I know it's positive because both 3.28 and 5.3 were positive numbers. All right, I want you to go ahead and do number 5. In number 5, remember this is an exponent, so it's only applying to the negative 1.6, so don't drop that subtraction sign. And then you've also got this multiplication here too. So think about your order of operation. Try that one out and send me your answer in a direct message. Okay, so remember, we need to focus on the exponent part first. So we're going to do negative 1.6 times negative 1.6. So negative times negative is going to be a positive. So we know that value will be positive. We set up the multiplication. 6 times 6 is 36. 6 times 1 is 6 plus 3 is 9. 1 times 6 is 6. And 1 times 1 is 1. We'll add. 9 and 6 is 15. And we get 256. Now it's not 256 because we have two decimal places. And so we end up with 2.56. So if we go up here and we simplify this, that means I've got 3.2 times negative 2.5 minus 2.56. The reason why it's still minus is because this subtraction sign there in the middle, it was always there. We're just squaring the negative 1.6. So now we need to do the multiplication of 3.2 times negative 2.5. So 3.2 times 2.5. Didn't multiply correctly. What did I miss? Oh, that's a 6, not a 5. That's the problem. And then we have to have two decimal places in. And since this is a positive 3.2 times a negative 2.5, we end up with negative 8.00. I leave the two decimal places in there because we're going to need those places to be able to add or subtract these numbers. So it's negative 8.0 minus 2.56. So that means we're going more negative. We're going to add these two values up, but our answer is going to end up being a negative number because again, we're starting at negative 8, we're subtracting, so we're going more negative. And we end up with a negative 10.56 as our answer. So there's a couple of places where we can make a mistake there, right? We're multiplying the negative 1.6 times itself, meaning squaring it. We know our answer has to be positive, but we can't ignore that subtraction sign that was already there. We have to keep that. Okay, so number 3 and number 6 both have absolute value signs. So remember, when doing these, you simplify what's inside first, and then you take the absolute value, which remember means if the value is positive, it stays positive. If the value is negative, it becomes positive. So go ahead and do number 3 and send me your answer. Okay, so let's talk about this one. First of all, when we focus inside those absolute value signs, we've got this double minus happening here, okay? So that means we're gonna have 15.88 minus, and then absolute value of negative 5.22, now plus 19.94. So simplifying inside means that we're adding those numbers together, but because one's a negative and one's a positive, we're gonna subtract. We're going to do 19.94 minus 5.22, giving us positive 14.72. So rewriting, I've got 15.88 minus the absolute value of 14.72. Now, because what's inside the absolute value sign is positive, we don't really have to worry about it because, again, the absolute value of a positive number is just a positive number. So if we take the absolute value, we've got 15.88 minus 14.72. Again, we can't forget that subtraction sign. So setting up our vertical subtraction, 8 minus 2 is 6, 8 minus 7 is 1. Bring our decimal point down. 5 minus 4 is 1, and 1 minus 1 is 0. So 1.16 is our final answer. All right, I'm going to skip number 6 because we're running low on time. I want to make sure we get through as much of this as possible. So we're going to go to the next page, and we're going to talk about multiplying decimal numbers by powers of 10. So multiplying by a power of 10 will move your decimal point. If your exponent is positive, which is what we're going to deal with, it's going to move it that many times to the right. So if I look at this number, I've got 3 zeros. So I'm going to be multiplying it by 1,000, which means it's going to move our decimal point 3 times to the right. So this is 10 to the third. So that's going to cause this one to move 1, 2, 3 times. So we end up with So that's all that multiplying by powers of 10 does. It moves it that many times to the right. So in number 3, I've got an exponent of 4, which means we're going to move this decimal point 4 times. So we're going to go 1, 2, 3, 4. It ends up between the 6 and the 3. So we end up with 1,586.314834. Okay, so go ahead and do number 2, and we'll talk about number 4. So this wasn't a trick question. Again, we're just relating the fact that 1,000 is the same as 10 to the third. And so we do get the same answer. So we get 12,343.5476. So number 4, we're taking 2.758 and we're multiplying it by 10 to the 6, which means we have to move the decimal point 6 times. But we only have 3 numbers here, right? So we have to keep moving it. So you can see if I just move it 3 more times, I'm moving it in thin air. We've got to have something there. And so we're going to add zeros. So we end up with 2,758,000. 30,000 is our final answer. All right, so with decimals, we're now going to cover circles. So a circle is a collection of all points equidistant from a given point O, which is called the center of the circle. So if I were to have this be my center, we'll call it C, and I were to draw these dots equidistant, and obviously I'm doing a terrible job because I'm freehanding this, if these dots get closer and closer together, they eventually will form what looks like a straight line. And again, my drawing skills are terrible, but we get the idea of how we can say that a circle is a collection of dots. When you're looking at this circle on the right, you're like, Erin, that's a solid line. What are you talking about? But if we were to zoom in, it's all these little points that are right up next to each other. So any segment joining any point on the circle to the center of the circle is called the radius. So this is a point on the circle. This is the segment joining it to the middle, and that's the radius. The diameter is the distance straight across. And so 2 points in a circle are connected with a line, and the segment is called a chord. However, if that chord passes through the center of the circle, then it's called the diameter of the circle. So one thing to know is, remember from our previous drawing, from here to the edge is called the radius. Therefore, if I have two of them, two radiuses equal the diameter. So why do we want to know this stuff? Because we're talking about the circumference of a circle. So the length of a circle is called the circumference. That's the distance around the thing. So whenever the circle's circumference is divided by its diameter, the answer is the constant pi. So pi that we know, right, that we're aware of, or that is used in pop culture or whatever, 3.14, which is why like 2 weeks ago, right before spring break, there was Pi Day and everybody was very excited about it because it was March 14th. And so 3.14, 314. But actually pi is this infinite number. It never stops, it never stops going. So it doesn't repeat, it doesn't terminate, it just keeps going. And so like people have these competitions for how many digits they can memorize of pi, but there's an infinite number of digits because it never stops. And the whole way they found this relationship was taking the circumference of a circle and dividing it by its diameter. And so in modern times, usually multiply both sides of this equation by d to obtain the formula circumference equals pi times diameter. Because the diameter is twice the length of its radius, we can substitute 2r for d, and we get that the circumference is equal to 2 pi r. So here we have pi for the first 15 digits, but for the most part, we round it to 2 decimal places or 3.14. We're finding the area of the circle. It's found by squaring the radius and then multiplying it by pi. So pi area equals pi r squared. So the next page we want to find the circumference and area for the given circles. So first of all, circumference is equal to the diameter times pi, or 2 times the radius times pi. And we're going to use 3.14 for pi. We also have that the area is equal to pi r squared. And we know that the diameter is equal to 2 of the radius. So how do we use all these pieces? Well, let's look at number 1. It says the circle has a diameter of 3.4 inches. And it says find the circumference and the area. So if we find the circumference first, we know the circumference, if we're given the diameter, we want to use the formula that says diameter times pi, and we're going to let pi equal 3.14. So we're going to say the circumference is the diameter times 3.14. In our example, we have a diameter of 3.4 inches. So the circumference is 3.4 inches times 3.14. So go ahead and multiply those two numbers together and send me your answer in a direct message. Okay, so if I multiply these two numbers together, I get 10.676 inches. If we go back up to our instructions, it says round to the nearest hundredth. So, and I didn't say that to you to begin with, but that means we want to round this answer to the nearest hundredth, which remember is 2 decimal places. So if I look at the 7, that's the digit I want to round. Remember, I look to the right of it and decide what does that number say. Since 6 is greater than 5, it's telling us that 7 needs to round up. So we get 10.68 inches as our circumference. The second part is we need to find the area. Now the area is pi times the radius squared, or in this case, the area is 3.14 times the radius squared. But we don't have a radius, we have a diameter, right? So we need to remember the fact that the diameter is 2 times the radius. So if we know our diameter is 3.4, we can then divide by 2, and we get a radius of 1.7. So we're going to go up to our formula. We've got the area is equal to 3.14 times the radius squared. And remember, squaring is multiplying it by itself, not multiplying it by 2. So go ahead and finish that. Round your answer to the nearest hundredth like you need to, and then send me your answer in a direct message. Okay, so if we square 1.7, we get 2.89. So we've got 3.14 times 2.89. That 2.89, remember this is 1.7 inches times 1.7 inches. So when I multiply inches times inches, I end up with inches squared. Okay. So now when I'm multiplying 2.89 times 3.14, I get 9.0746 inches squared, or square inches. Again, we have to use that unit of measure because we're talking about area. Area is always in squared units. So then we need to round to the nearest hundredth. So the 7 is in the 100th position. We're looking at that 4 to determine what we do with the 7. The 4 is less than 5, so it means the 7 stays the same. So we end up with a 9.07 inches squared as our final answer. Okay. All right, so number 2 says the circle has a radius of 2.3 inches. So if we were to make that drawing with the terrible circle, there's my center, there's my radius, and it's 2.3 inches. So we need to find the circumference and we need to find the area. I kind of wrote into our space here. Okay, so I want you to think about all the information we have up here. And I want you to find the circumference of the circle and the area, please. Okay, so the circumference, because we have a radius, we have to look at the equation that has the radius written. And that's 2 times the radius times pi. So we're going to do 2 times the radius, which is 2.3, times pi, which is 3.14. So 2 times the radius is going to be 4.6. So 2 times 2.3 is 4.6. Then we're going to multiply it by 3.14, which gives us 14.444. And since we run around to the nearest hundredth, we get 14.44 inches. And again, for circumference, that's just a linear measurement. So it's just inches. It's not inches squared. For area, we're going to square the radius and multiply it times pi. So we've got 3.14 for pi, and then we're going to multiply it by 2.3 squared. Again, you have to do the exponent part first before you can multiply it times 3.14. So 2.3 squared, or 2.3 times 2.3, is going to give us 5.29. Then we need to multiply 5.29 by 3.14, which gives us 16.6106. Again, rounding to the nearest hundredth is going to give us 16.61 inches squared. Because again, area is units squared. So questions about number 2 before we move forward. Yes, Frank has questions. All right, so let's go to the next page. So now we're going to talk about dividing decimals. So when we're dividing, we've got the dividend, which is the number underneath your division symbol, the divisor, which is the number outside, and the quotient. If we do, oh my gosh, I'm going to sneeze. And my cat's meowing a ton. If we do all the division, we're going to get that remainder down at the bottom. If we were looking at this in, as it's written, like we're trying to interpret the problem, we're going to have the dividend written first, then our division symbol, and then the divisor written second in terms of understanding where those pieces go. So the first part always goes under your division symbol. The second part is what goes outside in front of your division symbol. When dividing with decimals, it's a little bit different because we have to deal with those decimal values. So we're going to set up the long division as you would set up division of 2 whole numbers. We perform the division as if the numbers were both whole numbers, adding zeros to the right of the decimal point in the dividend if as necessary to complete the division. We place the decimal point in the quotient immediately above the decimal point in the dividend. So we're currently dividing a decimal by a whole number. So I've got 42.55, and I'm dividing it by 23. So I'm just going to divide this in. So 23 goes into 42 once. And we're going to put our decimal point right above. You just place it right above. And so 1 times 23 is 23. We'll subtract. We have to borrow here because we're doing 2 minus 3, which we can't do. So we have to do 12 minus 3. 12 minus 3 is 9, which is left with 3, and 3 minus 2 is 1. Again, 19 is less than 23, so we have to bring this 5 down. So now we're going to do 23 into 195, and that goes 8 times. 8 times 3 is 24. So we'll put a 2 or 4 there, excuse me, and we'll carry a 2. 8 times 2 is 16, plus 2 is 18. So now we'll go ahead and subtract. 5 minus 4 is 1. 9 minus 8 is 1, and 1 minus 1 is 0. So we don't have to write anything. We'll bring this 5 all the way down. So now we're going to do 23 into 115, and that goes 5 times. A hint about how I knew it went in 5 times. I need to remember, what can I multiply 3 by to get a 5 at the end? Because I'm looking at this 5 right here. And I know 5 times 3 is 15. And so let's try that 5. So 5 times 3, like I said, is 15. We're going to carry the 1. 5 times 2 is 10, plus 1 is 11. And so this goes in and a whole number of times. There's no remainder. So 42.55 divided by 23 equals 1.85. So I want you to go ahead and try number 2. It also is going to go in an even number of times, or a whole number of times, excuse me. There's not going to be a remainder. So send me your answer when you're finished. What are we yelling about? What are we yelling about? Stop. Oh. The cat has decided that it's time to be very needy. All right, so if we divide this, we've got 70.05 divided by 15. So 15 goes into 70 4 times, because 4 times 15 is 60. We'll go ahead and subtract, which is 10. We'll bring down this 0. And 15 goes into 100 6 times, because 6 times 15 is 90. We'll go ahead and subtract, and we get 10 again. But now we're bringing down a 5. Oops, that doesn't look like 5. And 15 goes into 105 7 times. And 7 times 15 again is 105. And we get 0 as our answer. So 4.67. And again, remember, you got to place that decimal point directly above where it is. So on the next page, it talks about dividing decimal numbers by other decimal numbers. So on this page, it was just a decimal number being divided by a whole number. And so now we're dealing with decimal numbers being divided by decimal numbers. So in order to divide, we first have to get rid of the decimal in the divisor, and that's that first number outside. So I look at number 1, and it's 0.09 dividing into 3.465. So I can't have that decimal there. So what I need to do is I need to get rid of it. So how many times do I need to move it? Well, I need to move it once and twice to get it all the way around the 9. So if I move that decimal point twice, that means I have to move the other decimal point, the divisor, or the dividend, the one underneath the division symbol, twice as well. So if I move that twice, we're going to go around the 4 and under the 6. And so it ends up right here, which means I would put it up there. So sometimes it's easier to now rewrite this because we have all these little lines. So what we're really doing is 9 into 346.5. That's the problem we're really doing, okay? So again, if the number of times you have to move it in the divisor is the same number of times you have to move it in the dividend as well. And then once you do that, you'll place it up above, just like we were. And then we move forward as if we're just doing this division by a whole number. So go ahead and finish number one. It's going to go into a whole number of times. So you'll get a 0 as your remainder. So if we divide this, we get 38.5. So how do I get 38.5? Well, 9 goes into 34 3 times. 3 times 9 is 27. So I'm going to subtract and get 7. Bring our 6 down. 9 goes into 6 8 times because 9 times 8 is 72. We'll bring our 5 down. 9 goes into 45 5 times. And we get 0 as a remainder. So again, 38.5. So I want you to think about what we did in number one, and I want you to try number two. Remember, you've got to move the decimal point at least once. I'm not sure how many times. It's up for you to decide. So try number two and tell me your answer. He's sitting behind me screaming right there. I don't know what he wants. He just gets this way sometimes. And he's a Siamese, so of course, you know, they never stop talking. Yes, you're fine. All right, so it's 2.2 that is what we're dividing into 54.12. And again, we can't have a decimal number, so we have to move that decimal place once. So we're gonna move it once, which means we need to move this one once. So we're gonna get 22 dividing into 541.2. So 22 into 54 goes in 2 times, because 2 times 2 is 44. We'll go ahead and subtract. That's going to be 10, and we'll bring down the 1. This is going to go on 4 times. 4 times 22 is 88. We can't do 5 times 22 because 5 times 22 is 110, and we're looking for 101, right? So 101 minus 88 is going to be 13. We're going to bring this 2 down. And so how many times does 22 go into 13? It goes in 6 times, and 6 times 22 is 132 as well. And we get 24.6 as our answer. So the biggest thing there when you're dividing a decimal by another decimal is that whole beginning part of moving that decimal point at the beginning, right? For the divisor. Okay. So 5.5, we're going to start this. It's already 3:30, or not 3. It's 3:30 for me. I live in Knoxville, Tennessee now. So I am in the Eastern time zone. So it is only, what, 1:30 for you, which means we only have 15 minutes left of class. So we are going to talk about converting fractions to decimals. Okay. So there's different types of decimals we can have. We can have a terminating decimal, which is where the number ends, right? You divide in until you get a 0 and you're done. Or you can have a repeating decimal where you keep dividing and you keep getting the same value over and over and over again. A really common denominator that's going to give you a repeating decimal is 3 or 6 or 9 especially. And then you have this repeating bar that you're going to use to show that it repeats. So we're first going to divide 5 by 8. So remember, when you have the numerator, that's what goes underneath the division bar. The denominator goes outside. And so 5 divided by 8, 5 is less than 8. So we have to add a 0, which means we have to add a decimal point, right? So now I'm going to do 8 into 50. So 8 goes into 50 6 times. 6 times 8 is 48. We'll go ahead and subtract. We have 2. Okay, we haven't terminated. So we still have to keep going until either we get a 0 or we start getting a repetition. So we have to add another 0. And we're going to bring that down. 8 goes into 20 twice because 8 times 2 is 16. We'll go ahead and subtract and we get a 4. Again, we're not done, so we have to bring a 0 down. And 8 goes into 45 times. And 8 times 5 is 40. And so now we have finished. We have we found it's a terminating decimal because it ends because our division ends in 0. So 5/8 is equal to 0.625. So 0.625 is the decimal equivalency to 5/8. Okay. So I want you to go ahead and do number 3. We're going to take 15 and divide it by 16. I'm letting you do that one because I'm going to tell you right now, it does terminate, meaning as you do the division, eventually you will get a 0 as your at the end of your subtraction. So go ahead and do that. Okay, so we're taking 15 and we're dividing by 16. This one goes on for a while. So we're going to add a 0 because 16 doesn't go into 15. So 16 goes into 150 9 times. So 9 times 6 is 54. Carry the 5. 9 times 1 is 9 plus 5 is 4. We'll go ahead and subtract. We get 6. Again, we need to bring a 0 down. 16 goes into 60 3 times. 3 times 16 is 48. We'll subtract, and now we get 12. So bring another 0 down. 16 goes into 120 7 times. And 7 times 16 is 112. And we get 8. And so we're going to bring another 0 down to get 80. And 16 goes into 80 5 times. 5 times 16 is in fact 80. And we get 0. So we know we're done. That's a big one. So 15 16ths is equal to 0.9375. So let's look at number 2. We have 23 nines. So remember me telling you that 9 was a really common number to cause these repeating decimals. So we're going to take 23 and we're going to divide it by 9. Well, 9 does go into 23 a certain number of times. It goes in twice because 9 times 2 is 18. So we can subtract. And 23 minus 18 is 5. So we're going to add a 0 and bring that down, which means we had to add a decimal point. So 9 goes into 50 5 times because 9 times 5 is 45. And we subtract and we get 5 again. So we're going to add a 0 and bring it down. And you're like, well, wait a minute. And we just did 50 divided by 9 because 9 goes into 50 5 times and we get 45. And oh my gosh, we start getting into this loop and we never will stop. And so what that tells us is that we have a repeating decimal because we keep getting 5 as our remainder, which means when we bring a 0 down, we have 9 going to 50, and that just keeps happening. And so the 5 is going to keep repeating an infinite number of times, and we can't write an infinite number of 5s, right? So what we do is we do 2.5, and then we put a repeating bar over the 5. And that tells us that that 5 part keeps repeating. And so instead of like writing a million 5s out, we just write 1 with the repeating bar, and that tells us all what's happening, okay? So 4 7ths is another crazy one. 7 causes these repeating decimals too. So if I do 4 divided by 7, again, 7 can't go into 4. So I'm going to add a decimal point and add a 0. 7 goes into 40 5 times because 7 times 5 is 35. Subtract, we have a 5, bring a 0 down. 7 goes into 50 7 times because 7 times 7 is 49. Subtract, and we get a 1. So we'll bring another 0 down. 7 goes into 10 once. We get a 3. Bring a 0 down. Extend my fraction bar, or my division bar, excuse me. 7 goes into 30 4 times because 4 times 7 is 28. Subtract, and we get 2. Bring a 0 down. 7 goes into 20 2 times. 2 times 7 is 14. And we get 60. We're bringing a 0 down. And I am running out of room. 7 goes into 60 8 times. And 8 times 7 is 56. And when I subtract that, I get a 4. So what does that mean? Well, now I have to look at how many times 7 goes into 40. And if you think about where did I start? Well, I started right here with a 4, which means if I take 4 and I divide by 7, I get this crazy long repeating decimal. because once I hit that 4, that whole pattern is going to start again. 7 goes into 4 5 times because 7 times 5 is 35. When I subtract, oh, I get a 5. So then I have to do 50 and so forth. So what that means is this whole long thing repeats. And that's a crazy decimal one. So 4/7 is equal to 0.571428 repeating. And again, let's talk about how do I know that? And it's because of the pattern. Unfortunately, I ran out of room, so you can't really see it on our screen. But because that pattern of suddenly getting that remainder of 4 at the end, this one right here, I know that if I were to keep dividing, I'd have to add a 0 to it, which would be 40, which would put me right back up here. And I've already done all that, right? And so what that says is that by doing it that number of times, I'm going to eventually repeat the pattern. I'm going to have to keep going. And so it is equal to this repeating decimal. Okay, that is our time. I'm going to go ahead and stop us there, and we will pick this up on Wednesday. So I didn't think we're going to get fully through 7.5, which is fine. We still have one page left of it, and we'll talk about that on Wednesday. So to reiterate, what do we have going on? What do we have due? So tonight we have homework 5.1 and 5.2, which was way before spring break. So I hope you got it done. And then tomorrow you have test 3 due. And then Wednesday I'll teach 5.6. And then all the homework from this week, 5.3 through 5.6 is all going to be due next Monday. Okay. So again, get 5.1 and 5.2 done, and then get the test done tomorrow if you don't get it done today. Okay. All right. We did a lot today. We used up all of our time. So I hope you have a good rest of your day, and I will see you all on Wednesday. Okay.
Thank you.
Bye, everyone.